Hey everyone, welcome back to another math video. Today's video we're going to be talking about the incenter of a triangle. Let's go ahead and let's get started. So recently we also discovered what the circumcenter was. The circumcenter is very similar to the incenter. The circumcenter takes a triangle and draws perpendicular bisectors on each side. The difference between a circumcenter and an incenter is that an incenter draws angle bisectors on the angles inside a triangle. So essentially what we have here is the incenter is what we get when I split all of these angles in half. Say I draw a line going out that way. I actually don't need it that long, so let me redraw it. And then I go to the top angle. I split that one in half as best as I can. And then the last angle as well. This point that we have right here is what we call the incenter. It's the point that's the product of drawing an angle bisector on each of the points of a triangle. Okay, so today we're going to focus on this point. We're going to look at how it affects the triangle in terms of like which of these sides, which of these line segments are equal to each other. And then we're going to look at a couple problems that have to do with the incenter. So let's go ahead and start off by looking at a much nicer drawn picture of what the incenter is. So angle bisectors intersect at the incenter. So when this happens, we know that these angles, okay, all of these angles that were in the triangle automatically get split in half. So angle A is now split into two equal smaller angles. Angle B in the same way split into two smaller angles that are equal to each other. And so is angle C. The other thing that is special about this incenter is that the incenter is equidistant from all the sides. So if I draw a line going directly from this point to the sides, so if I draw a line going from, I'm going to draw in blue, from N to this side, and then from N to this side, and then from N to this other side, all of these lines in blue here are equal to each other. Okay? So this is another thing that's special about the incenter. So if I know one of them, I know all of them. If I know what one of the angles is, I know what those halves are going to be when I split it up. So now let's go ahead and let's look at a couple problems that use some of these properties about the incenter. So two of the angle bisectors of ABC are AP and BP. So let's go ahead and draw those out in red, so that we know which ones are the angle bisectors. We know that from A to P, so this is an angle bisector, and from B to P. Okay, the other thing I know by them being angle bisectors is that they cut these angles in half, so I know that this angle is equal to that one, and I know that this angle is equal to that one. Whether or not I'm going to have to use this, I don't know yet, but I like to draw it out just so I know. Alright. So it wants us to find each of these values. So the other thing that we know about point P, okay, point P is our incenter, which means from point P to each of the sides, those are all going to be the same length. So JP, KP, and LP are all the same length. So the first question asks, what is the value of PK? Well, from P to K is the same as from J to P. All of those, even PL, all of those have the same distance of 5. So I know PK is 5. The next question that we get asked is, what is the perimeter of APL? So let's go ahead and highlight that triangle in green from APL. They're talking about this lower triangle right here. They want to know what is just the perimeter of that triangle highlighted in green. So some of you might be wondering, how are we going to do this? Well, we can make use of a very popular math theorem called Pythagorean theorem. We also use this for some of the problems in the Circumcenter. And basically, if we know two sides of a triangle, we're able to find the third side. The one side that I do not know right now is the distance between A and L. I know from A to P is 13, from P to L is 5. In order to find the perimeter, I am missing this side right here with the question mark. I do not know what that side is. So I have the hypotenuse, I have one of the legs, so we can use the formula a squared plus b squared equals c squared. Okay, where a and b are legs and c is the hypotenuse. So for this example, we're going to make c 13 because that is the longest side of this right triangle. We're going to go ahead and we're going to make b 5, and we're going to say that we don't know what a is. So I get a squared plus 25 equals 169. 5 times 5 is 25. 13 times 13 is 169. We can then subtract 25 from both sides. I end up getting a squared equals 144. We now want to take the square root of each side. And I get that a equals 12. So now I know that this distance is 12. But that's not really the end of the question. The question asks, what's the perimeter of that triangle highlighted in green? So the perimeter would be the sum of all of its sides. So I know that the perimeter is going to equal 12 plus 5 plus 13, which, adding all of those up correctly, we get 30. So I know the perimeter of APL is 30. So hopefully now you feel confident in being able to find an incenter in a triangle. All we have to do is bisect each angle and find where those angle bisector lines meet. The point where they meet, that's our incenter. And hopefully now you're familiar also with the properties that come with the incenter that we can use to solve some of these geometry problems. As always, if you need to rewind, rewatch, go ahead. There's nothing wrong with that. Keep watching it until it sticks. That's how we learn. Okay, and as always, stay tuned for more videos for triangles. The next ones I'm going to be doing have to do with inequalities in triangles, so definitely stay tuned for that. As always, I hope you learned something new in math. Thanks for watching, and I'll see you guys in the next video.